Let's make our own dry ice here. I'm using a CO2 extinguisher and have a cloth towel on the nozzle while the CO2 is being let out. This condenses the gas and turns CO2 from a gas to a solid. This process is opposite to sublimation and is called deposition. And once again, when we add water, it becomes the gaseous CO2, and this is called sublimation. Here we have taken dry ice in a bowl and allow it to sit for a few minutes so that the CO2 fills the bowl and stays in the bowl, as the CO2 is heavier than air. Now soap bubbles are dropped into this bowl, and just like a scene from Mission Impossible where Tom Cruise lowers himself from the ceiling and stops just before he hits the floor, the bubbles also suddenly stop before hitting the bowl and float in air magically. This is again because the air bubbles will float on CO2 layer of gas inside the bowl. This again is because air is lighter than CO2 gas. Here we are adding some warm water to the dry ice, and using a thick string dipped in soap water is gently swiped over the edge of the glass bowl, and soon we have a large bubble of CO2, growing in size bigger and bigger until it pops. Here we added a few pieces of dry ice to a balloon and tied it up as soon as we drop it into some water. It begins to grow on its own. As the solid CO2, the dry ice expands to become a gas. It occupies more space and hence stretches out the balloon. This is a race. Which balloon will drop first? The balloon A, which is filled with air, or the balloon B, which is filled with CO2? Take a guess. So were you right? And do you know the reason? Yes, CO2 is heavier than air. That's why it drops first. This is regular ice and it floats on water. Why? Let's do that in another video. And here we have dry ice and it sinks to the bottom as it is heavier than water or more dense. In a gas, all the molecules are spread out over a large space or an area. But in a solid, all the molecules are jam-packed into a tiny area, thus creating a huge dense body. That is why dry ice sinks into the water. When dry ice expands, or let's talk about the expansion ratio of dry ice, it's approximately 1 to 554. In other words, 1 unit of dry ice expands to 554 units of gaseous CO2 during sublimation. Dry ice is a solid form of carbon dioxide. One molecule of a single carbon atom bonded to 2 oxygen atoms. Dry ice is colorless, odorless, and non-flammable, and can lower the pH of a solution when dissolved in water, forming carbonic acid. Very tiny pieces of dry ice will float on water due to the surface tension of water, as seen here. Dry ice sublimes at 194.7 Kelvin or minus 78.5 degrees or minus 109 Fahrenheit at Earth's atmospheric pressure. Dry ice was discovered by French inventor Adrien Jean-Pierre, who later on applied for a US patent to sell dry ice commercially, and then which subsequently became a huge industry. Dry ice is produced in large industries. It starts off with a gas having a high concentration of carbon dioxide. Such gases can be a byproduct of another process, such as producing ammonia from nitrogen and natural gas. Secondly, the CO2-rich gas is pressurized and refrigerated until it liquefies. Next, the pressure is reduced and this causes some of the liquid carbon dioxide to vaporize, causing a very rapid lowering of temperature of the remaining liquid. As a result, the extreme cold causes the liquid to solidify into a snow-like consistency, and then the snow-like solid CO2 is compressed into small pellets or large blocks of dry ice. So here, in case you have to handle it, keep juggling it from hand to hand. Do not keep it long in one hand. Remember, handling dry ice requires precautions due to its frostbite inducing coldness and potential outgassing effect. The rattling sound produced here is due to the dry ice expanding and causing fractures in the dry ice, and the sound can increase when pressure is increased as this speeds up the sublimation process. That is why when you press a spoon or a metal object against dry ice, you get a louder sound. This causes a cloud of frost to build up underneath the dry ice that acts like a cushion and helps it float over the surface. This effect was discovered by Johann Leidenfrost. Give the dry ice a little nudge and it will glide as though it's skating like a pro ice skater on an ice rink. It actually glides over a layer of gaseous CO2 that makes it like a hovercraft by the smoky cloud or the frosty white cloud it produces. Just like hot water. When a liquid boils, a gaseous barrier is formed and acts as a thermal barrier. The key is a large temperature difference, but here there is nothing boiling, but there's a large temperature difference, almost a 200 degrees difference between dry ice block and the surface of the table. It was super cool to see patterns forming and moving. So what is happening here? Cold air contracting and expanding between two glass plates sandwiched. The dry ice makes the air between the two glass plates contract and get much closer to each other. As light is reflected and refracted, interference causes the different color bands to form. To understand this completely or more in detail, please check out the link provided in the description below. Dry ice, when subjugated to heat, moves or changes from a solid to a gas. It skips the liquid stage, and this is called sublimation. I and the kids had great fun using dry ice to create a creepy fog for Halloween. Thank you for watching and hope you enjoyed Science Rocks. This is Gerard Walter Ritchie.